Hi Geometry, this is Unit 5, Lesson 15 on page 619 of our workbook. We're going to calculate volumes of prisms, cylinders, cones, and pyramids. And spheres, actually. So on this page, this is going to be a do now in our class this week. So for this video, pause if you were absent from class, pause this video and try all four. Play the video to check your answers and come to office hours with any questions. So at this time, pause the video, try these four, and then come back, please. So I hope you did well on these four problems. If you had any trouble on calculating the volume of these three-dimensional shapes, then bring your questions to office hours. So let's take a look at the next page, page 620. These problems have a little more going on. They're not as straightforward because we're not given all the dimensions that we need. So let's take a look. Let's just draw a line down the middle because they're two different problems. So we're going to look at side A first. This is for the cone. So it says which measurements that you need to calculate the volume isn't given. So for the cone, my formula for volume is 1/3, because it's a cone, it goes up to a point, pi r squared, because that's the area of big B, my circular base, times the height. So I can see that I'm not given my radius. I need r, my radius. So how can you find this measurement? Well, my height is 7. My slant height on the outside is 8. So I could use this triangle, this right triangle, made of the height, the radius, and the slant height. To find r, I could use the Pythagorean theorem. Okay, we've done that before. So then it wants me to write down the formula that applies. I have it at the top of the page. It's 1/3 my big B, which is a circle, so that's pi r squared times the height. So now we have to do the necessary calculations. These calculations have two parts. There's a step 1 to find the radius, and then step 2. So let's do step 1 out to the side. Step 1, I have to find my radius. So let's set up my Pythagorean theorem. The hypotenuse is 8. So the 7 squared and the r squared go on the same side. They're my legs, and they should be equal to my hypotenuse squared. So 49 plus r squared should be equal to 64. Subtract your 49 over, and we get r squared equals 15. So then r is equal to the square root of 15, or approximately 3.9 units. So then it says to calculate the volume. We're going to calculate the volume. So my volume formula is right above. I'm just going to enter for it. So it is 1/3 pi. Now be careful here. It says r squared. So I'm not going to square 3.9 because remember, when I take the square root, I had to round to that 9. I'm actually going to use this line right here and just substitute in my 15. If you're thinking, well, I didn't even have to take the square root, you're totally right. Times then my height of 7, not 8. That's the slant height. And when I multiply the 1/3 times 15, I actually get 5. 5 times 7 is 35. So my volume could be written as 35 pi units cubed. And you could multiply the 35 times pi if you wanted to. So let's take a look at B. B is a rectangular prism because there is a top base and a bottom base. It's a 7.5 by 4.5 rectangle. And it says, which measurement do I need to calculate the volume? Well, I notice I don't know the height of this guy. And remember, the height would be the perpendicular distance between, and you can draw it many places. It's right here too. It's the perpendicular distance between the top of my rectangular prism, the top base, and the plane on which the bottom base sits. So my height is drawn in two places. So I need my height of my prism. It says, how can you find it? Well, looking at the left side here, I notice there is a right triangle made from my height, this 3 meters, and my 65 degrees. So it looks like I could use my trig to find my h. Which formula applies for this? Well, this is a prism, so my volume is big B times H, where in this case, my big B, my base, being a rectangle, means my volume formula is length times width times the height I need to find. So it asked me in part D to find the volume. So before we can find the volume, we need our height. So step one in this problem is to find the height. So let's take a look at our trig triangle. If this is my angle, the 65 degrees, H is my side opposite, and 3 millimeters is my side adjacent, and my hypotenuse is blank in this case. So this looks like I'm doing an equation with opposite and adjacent, which is tangent. So tangent of 65 equals opposite H over adjacent 3. Let's multiply the 3 over. So 3 times tangent of 65 is what the height is equal to. So plugging that into my calculator, I found that I got 6.43. Now, depending on how you round, what number you carry into your calculations, again, your final answer could be slightly different than mine, but still correct. So my volume formula is my length, 7.5, times my width, 4.5, times my height, 6.43. And when I multiply all three of those together, I get 217.01 meters cubed. Now, if you use the entire number on your calculator for H, all the decimal places, you actually get a slightly higher number, 217.03, if I'm not mistaken. Those answers are all correct. Again, it depends on how many decimal places you bring to your calculation. So let's take a look at 2 down here at the bottom of the page. So these two problems are similar to the above. There's some dimension missing for my volume. So let's discuss what that's missing. In the first one, I can see that this is a triangular prism. It's got a top and bottom. And I can see that I have a 48 and a 73, but I don't know this side of my triangle, which is a really important side because this is where my right angle is located. So before I can do my measurements, I would need to find this measurement for my area of my triangular base. Looking at B, when I look at this cone, I don't have a height, nor do I have a radius. Oh, that's 2 missing parts. So I do know on both sides that my slant height is 10 inches. So for both of these problems, I'm going to have you pause the video and try them on your own, and then come back. I'm going to do both problems with you in the video. So if you notice that you have the correct answer, you can skip that explanation. And if you didn't get the correct answer, then listening to the video will allow you to maybe spot your mistake. So at this time, pause the video and try A and B. Welcome back. So the answer for A is 40,920 centimeters cubed. So if you got that answer, you can fast forward a little bit to B's explanation. If not, I'm going to discuss A for a moment. So in this problem, this side of my triangular base, I need it because a triangle's area is 1/2 base times height, and the base times height have to be the two sides that are perpendicular to each other, the legs. So I used the Pythagorean theorem, and then I got my x to be 55. When I plug that in, I have 1/2 48 times 55. That is my big B. That's the area of my blue triangle, times my height of 31. This isn't distribution property or anything like that. It's just all multiplication for numbers. So I see this as 1/2 times 48, which is 24, then times 55, then times 31, and you get your final answer. Moving on to B. You might have a slightly different answer than me. A lot of it depends on, did you use trig or 30, 60, 90 to find your height and radius? Did you use rounding? Did you truncate? Did you use all the decimals on your calculator? So our answers are, did you leave it in terms of pi? Our answers will fluctuate a little bit, but they'll all be about the same number and correct. So starting out on this problem, I did not know the height, nor did I know the radius. So you could use 30, 60, 90 rules. I did my work in trig because more students gravitate back to trig than the 30, 60, 90 rules. So let's find h. When I find h is the side opposite. 10 is my hypotenuse, so I set up a sine equation and found my h is 5. So to find my radius r, I'm going to not use my 5. I tend to try not to use my numbers that I found with my work. So I'm going to use my r and my 10. That is the side adjacent and my hypotenuse to the 30 degrees. So I set up a cosine equation. And this is where you might start having different numbers. I used 8.66. If you use 8.7, your answer is slightly different. If you use 8 point and all the decimals on your calculator, your answer is slightly different, slightly, but close. So again, that part of it is just personal preference, and it happens. So now I go to put this in my volume formula. So we have the volume of our cone. Don't forget your 1/3. And so when I plug everything in, since I already had a decimal value, I didn't use pi. I went ahead and just multiplied, again, by the pi button on my calculator. If you use 3.14, that could cause decimal differences again. So when I do that, I get 392.7 inches cubed. Again, your answer may vary slightly depending on your decimal. Okay, let's take a look at the next page. So on this page 621, we have this problem where it wants us to spin this two-dimensional figure around the axis, the vertical axis shown. And then it says to draw, number 1, the solid. So I notice that this is 2 squares over. So I know when it flips around, it'll be 2 squares over on this side, and it'll be flipping around in this circular manner. It'll be swinging around, if you will, creating this cone-like shape on top. And then my rectangle down at the bottom will also flip across, but as it's spinning around and around, it'll flip in such a way that it's creating this circular shape, this cylinder on the bottom part. So I actually have a cone on top and I have a cylinder on the bottom. So it says to find the volume of this solid. So I need all the parts of my volume formula. For my cone, looks like the radius is 2 and my height is 3. For my cylinder, it looks like my radius is also 2 and my height is 1, 2, 3, 4, 5 units tall. So pause this video and calculate the volume of this entire solid in part 2, and then come back and check your answer. So welcome back. So your answer should be 24 inches cubed or 75.4 inches, 24 pi inches cubed. Or if you multiply 24 times the pi, you should get 75.4 inches cubed. So notice, just double check that in the volume of your cone, you've got the 1/3, and the volume of your cylinder, you don't have that. And this should have been a straightforward problem. If you have any questions, make sure you bring them to our office hours. So let's take a look at the first 2 practice problems in your workbook on page 623. Both of these use a term that you haven't really seen before, so I want to sketch them both for you. So let's read number 1. It says a right cone has a base with diameter 10. So remember, a diameter is all the way across my circle. So when they say that, they're trying to tell me that my radius is 5. It says the volume is 100 pi cubic units. So that must mean I'm going to find my radius or my height. It says, what is the length? What is the length of the segment drawn from the apex to the edge of my circular base? Is that my radius, my height? Or is that my slant height? What is that? Let's figure out what this is. So let's trace a cone out to the side on our paper. And we have the radius down through the middle from my vertex, or this is also called the apex. This would be my height. And that side that they're talking about that goes from the apex to the edge of the circle base is this guy out here. So we have called that, or we've seen that in class, and we've called this yellow side, we've called this the slant height. So this problem actually wants the slant height. There's a lot of moving parts here. I know my radius is 5, but I do not know my height h, and slant height is also often abbreviated with an L. I'll use the L in my problem, but the L tends to look like other numbers for me. So if you want to use an X, you're welcome to. So this problem has a lot going on. I need to find H first. So my step one, I'm thinking out loud, my step one is going to be to find H. I can use my volume formula to do that. So my step two then will be to find what I'm trying to look for is my L. And it looks like I'm going to have to use perhaps my Pythagorean theorem because this would be a right triangle. So I could use my Pythagorean theorem, it looks like in this case. So this problem is similar to ones we've done, but it's actually backwards. Instead of using the slant height to find the height to find the volume, I'm instead going to use the volume to find the height to find the slant height. So I'm moving through my problem in a backwards manner. So let's get started here. For the lack of room, I'm going to write down this side of the page. So in this problem, step one, we need to find my height h. So my volume formula is 1/3. This is a cone, so the area of my base, pi r squared times my height. So my volume is 1/3 pi times r squared, which is 5 squared, times my height, which I don't know. Let me erase my volume and insert my volume, which I was told was 100 pi. So the first thing I would do given this problem is I notice it's all multiplication on both sides of my equal sign, and I have a pi on both sides. So I would cancel my pi. So now I have 100 equals, this is 1/3 times 25 times the height. I'm going to multiply the 25, which is over 1, times the 1/3. They're two fractions. So I get 100 equals 25 over 3 times the height. So now going back to previous courses, if you want to cancel a fraction, we do that by multiplying by the reciprocal of my fraction. So on my left side, I need to multiply by 3 over 25. The 25s would cancel and the 3s would cancel, and I would have just my height on the right. So if I'm going to do that on my right side, I'm also going to do that on my left side. So I'm going to multiply by that same 3 over 25. Here, my 25 and my 100 cancel, 4 and 1, and I get 12. My height is 12. I am only partway done with this problem. Once I know that my height is 12 up here, let me write that in. I now can use the Pythagorean theorem to find my L. So my step 2 was to find L, and I'm going to do that by using the Pythagorean theorem. My L is the hypotenuse, so this is going to be a 5 squared plus 12 squared equals L squared. And you can use your Pythagorean theorem to do this, or as a Pythagorean triple, you're going to get 13 for your slant height as your final answer. So let's look at number 2 for just a moment. This problem is similar, except this is a right pyramid that has a square base with side lengths 10, and each segment connecting the apex, that's the vertex at the top, to the midpoint of the side of the base has a length of 13. What is the volume? So let's sketch this one. You can do the volume part on your own, but let's sketch this. So let's draw that square pyramid. So I need my square base, and I have a vertex up here that I'm going to attach to all 4 corners of my base. And this is my square pyramid. I know it's 10 by 10, and its height, let's do the height in blue. The height of my pyramid goes from this vertex, this apex, down to the perpendicular to the base. And then it says that the segment connecting the apex to the midpoint of a side. Let me do that in green. This segment connecting the apex, that's up here at the top, to a midpoint of the side. Wow. Okay, so let's draw that segment in. So this is on top of the surface of my um, square pyramid. So this is really on the outside of my square pyramid. And I know that this green length is 13. I also know, going back to red, that if I attach where my height touches my pyramid and where my green um, segment that's 13 touches the midpoint of my edge, I know this is 5 because it's halfway across my square base. So what I can see inside here, let me grab a yellow highlighter. What I can see inside here is a right triangle made up of my perpendicular height, the green segment going from the apex to the midpoint of my side of my square, and the 5, which is halfway, the distance halfway across my square. There's a right triangle there. I could use the Pythagorean theorem to find my h. Once I've done that, I can use my h to help me find the volume of my pyramid. So hopefully that would help you understand the sketch that would give you the volume for number 2 in the practice. Well, I will see you in class geometry. Good luck with this.